Lesson 5, finding absolute value and adding real numbers. So the objective, you'll be able to find absolute value and add real numbers. So here, the set of blank includes all integers or real numbers. So which one is it? Yeah, it's going to be the real numbers. All right, and then let's just go ahead and jump into our lesson. So absolute value is the distance from the number 0 on a number line, no matter if it's positive or negative. So really the key word to think about here is the distance. Just if you're thinking about going from LA to New York or New York to LA, no matter which direction you're going, it's still going to be a positive distance that you're traveling. So therefore absolute value is going to be the positive distance to 0 on a number line. So here, if we look at the absolute value of 4, that's going to be 4. Absolute value of negative 4 is also 4, because remember, it's a distance, so it's going to be a positive value always. Here, these little lines right next to what we see here underneath simplify, so next to the 0, that just means what's the absolute value. Absolute value of 0 is just going to be 0, because it's neither positive or negative, so it's just going to stay the same. Here, we have 7.12, the absolute value is 7.12. The distance from 0, positive distance is going to be 7.12. All right, so let's look at a couple other more complex ones. So here, we got 1 minus 3/4. So 1 can be written as 4 over 4 minus 3 over 4. So it's just going to be 1/4. So it's going to be the absolute value of 1/4, which is just going to be 1/4. All right, then I'm just going to move this one over. Oops. All right, I'll keep that one there. All right, so here what we're going to do is we're going to do what's in between the absolute value grouping here. So we have 11 minus 2, so that's going to be the negative absolute value of 9. So the absolute value of 9 is just 9. But remember, we have that negative out there, so here this is actually going to be negative 9 just because that negative was out in front. Next slide. So go ahead and practice to see what the absolute value of these would be. We'll resume in 3, 2, 1. So here, absolute value of 12 is 12. Here, absolute value of negative 15. It might be 15 units to the left of 0 on a number line, but again, we're looking for the positive distance, so it's 15. Here, negative 2.5, we're looking at the positive distance, 2.5. 2, remember, here we have to do whatever is inside those absolute value grouping right here. So we have 2 minus 5 is negative 3, but we still have the absolute value of that. Absolute value of negative 3, positive 3. 3 plus 7 is 10. Absolute value of that is just 10. Let's keep going. All right, so adding integers with the same sign. So basically, we're just going to add the two numbers and keep the sign the same. So here, let's look at this. Negative 2 plus negative 7. We know 2 plus 7 is 9. We keep the same sign, negative 9. Here, two positive numbers, just add them together, and it's going to be positive. Here we have 13. All right, so adding integers with different signs. So basically what we can do is we can subtract the two numbers and keep the sign of the number with the greater absolute value. So looking at our first example, let's just go ahead and do 9 minus 5 is 4. We know that 9 is positive, so it's bigger than 5, so we're going to keep the positive sign, so this is going to be 4. Here, looking at this one, we have negative 8 and 3, so let's just do 8 minus 3. So that's going to be 5, but here we have more negative than positive, so it's just going to be negative 5. You can also just picture a number line and think if you're starting here at negative 5, move 9 units towards the positive end, and you're going to end up at positive 4. Also think about it, same thing here. If you're starting at positive 3 and then you move 8 units towards the more negative end, then you're going to end up at negative 5. So a couple of different ways to think about that. All right, so I'll give everyone 3, 2, 1 to go ahead and try these questions. All right, now we're going to go over it. So again, I can do 8 minus 5 is going to be 3, but it's going to take the negative one, so negative 3. On the other hand, we can just think about starting at 5 on a number line, moving 8 units towards more negative to get to negative 3. Negative 4 plus negative 3, add them together. They're the same sign, so we get 7, keep the sign negative 7. Negative 12 plus 4, so I'm going to do 12 minus 4 is 8, but the bigger one has a negative, so therefore it is going to be negative 8. And then here, 4 plus negative 3, I'm just going to do 4 minus 3. Positive has the bigger one, so it's just going to be 1. All right, so now let's go ahead and look at this example here. I'm just going to cut this out. So here, another way to think of absolute value, so maybe you're playing a game, like a board game, and let's say you win 9 but you lose 7. So you can think, oh, maybe if you were to like move 9 spaces up, but then go 7 spaces back, you'd have a net win or a net gain of positive 2, because 9 minus 7 is 2. Keep the sign that has the bigger value, in this case 9, the bigger absolute value. All right, so another way you can think about this is like football. Like if your first play you lose 4 yards, your second play you lose 2 yards. You're not doing too hot. So here, same sign. So just add them together and keep the sign, -6. And then here, maybe you have a short gain for 5 yards, but then tackle for a loss of 3 yards. So again, I'm just going to take away 3 from 5 and keep the positive sign, so we're still at 2 yards. So yeah, I think when we're like a board game, like moving spaces, or like playing football, going up or going back in yardage. All right, let's go ahead and look at finding the sum. So I'm going to give everyone 3, 2, 1 to go ahead and do this practice set. All right, so let's just go ahead and reveal answers. So again, number 1, we're keeping the same sign, just adding them together. Number 2, 9 minus 5 is 4, but the negative's larger, so -4. Let's just keep going through them, showing answers. Yeah, so just more practice, answers there. So again, see me in tutorial if you have questions. All right, simplify and solve. So I'll give everyone 3, 2, 1 to go ahead and pause your video and solve. So here, -9.3, absolute value is 9.3. Here we have the absolute value of 45 with a negative in front. So we do the groupings first. So absolute value of 45 is 45. So therefore, we're just going to end up with -45 because that negative is out in front. And we do the groupings, in this case, the absolute value grouping first. All right, so 14 plus -22. 22 minus 14 is 8. The 22 is larger and has the negative, so we're going to keep the negative sign. So we're going to get the absolute value of -8. Then that's just going to equal 8, because remember, absolute value is the positive distance. Here, 7 minus 16. I'm going to do 16 minus 7 is 9, but 16 is negative, so therefore it's going to be, we're going to get the negative absolute value of -9, and therefore we're going to get -9, because the absolute value of -9 is 9, and the negative out front stays there. All right, -2/3 plus -1/6. Whenever we add or subtract fractions, remember we just have to have that common denominator. So I'm going to do -2/3. All times 2/2 equals -4/6. And then all plus -1/6. So therefore we end up with -5/6 as our sum. And then lastly here, we get 33.3, -14.5 plus 33.3. So I'm just going to do 33.3 minus 14.5. So let's make this a 2, make this a 1. 13 minus 5 is 8. Keep that decimal point down there. I'll get rid of that. 12 minus 4 is 8. And then 2 minus 1 is 1. So therefore we get 18.8. And then 33.3 was positive and it's larger. So it's going to keep the positive, the 18.8. All right, identifying sets as closed or open. So a set of numbers is closed under a given operation if the outcome of the operation on any two members of the set is also a member of the set. So basically we just say that if there's a statement, we say the statement is closed if it's true in all situations. If it's false in one example, we call that a counterexample, and therefore it is not a true statement. All right, so the set of integers is closed under addition. So if I add any set of integers, we see that we're also going to get an integer. So this is true. Here, the set of real numbers is closed under addition. So any real numbers, that can be a rational number or an irrational number. We add any two of them, we're going to get another real number, whether it's rational or irrational, that's going to be true. We can see here, if we look at this for integers and for real numbers, the same applies for subtraction and also for multiplication. Where it gets a little iffy is with division. So we can see real numbers, we divide to any two real numbers, we're going to get a real number. But with integers, what we see here is, let's just say we do like 2/5, we're actually going to get a rational number. So therefore, the set of integers is not closed under division. That would be false. Okay, so false for integers. But then the rest of these, as we said earlier, all get true, true, and then division is true for real numbers. And that fancy R with extra line through it, that means all real numbers. Okay. So the practice set for lesson 5, so the lesson practice. Yep, so I'll give you 3, 2, 1, just want to talk about a couple. So here, 14 plus negative 22, there's nothing we can do with the parentheses on negative 22, so let's just combine it with 14. 22 minus 14 is 8, but since negative 22 has the greater absolute value, we see it's going to keep the negative, so therefore we have the absolute value of negative 8. Sorry, that's not the best arrow. And then therefore we see that that's just going to be 8. Want to look at GH and I. So here, the set of rational numbers is closed under addition. We just saw that. True. The set of positive integers is closed under addition. So any two positive integers added together will get another positive integer. That's true. And then let's see here. The temperature at 7 p.m. was 34 degrees Fahrenheit. The temperature fell 12 degrees by midnight. Use addition to find the temperature at midnight. So we're just going to do 34 degrees Fahrenheit minus 12 degrees Fahrenheit is going to be equal to, I'm just going to call this x, just the temperature at midnight, so that is going to be our unknown variable. So 34 minus 12 is going to give us 22 degrees Fahrenheit at midnight. All right, so again, we were just looking at finding the absolute value and adding real numbers. And solution to the lesson practice, we had our solutions to our lesson 4 homework. Lesson 5 homework is there. All right, thank you very much and have a wonderful day. We'll see you.